In this ACT video, we're going to take a look at multiplying polynomials. And in an earlier video, we reviewed some rules for exponents when multiplying polynomials, when multiplying variables. And so I'll remind you of a few of those rules as we proceed through the examples in this video. We're going to look at three types of problems you might see. The first one, we've got negative 4x squared times the quantity 5x cubed minus 2x plus 3y squared minus 1. And right here, this is just a common distributive property problem. We've got this monomial, this one term hanging out outside the parentheses, and we're going to have to distribute it through the parentheses. And we need to remember that when we multiply, we're going to need to add our exponents on the variables. So let's go ahead and jump in. We're going to multiply negative 4x squared times 5x cubed. Multiply our coefficients. Negative 4 times 5 gives me negative 20, x to the 5th. Negative 4x squared times negative 2x gives me plus 8x cubed. Negative 4x squared times 3y squared gives me negative 12x squared y squared. And negative 4x squared times that minus 1 gives me plus 4x squared. We don't have any like terms, and I also want to mention that we've written our answer here in what's called descending order. And by descending order, I mean we're looking at the variable x and it's getting smaller. In other words, we've got x to the 5th, x cubed, x squared, and then x squared again. Now we kept the x squared y squared in front of the x squared because it had an extra variable attached to it. But that's usually how we write our answers, is in descending order. Second multiplying polynomials problem you might see on your ACT is when you have a product of two binomials. So here we have 3x plus 6 times the quantity 4x plus 2. And when you look at that, you may remember the acronym FOIL. And that just reminds us to multiply each piece together. So we're multiplying, we're distributing, we're foiling. All those words mean the same thing. The F in FOIL means to multiply the first terms, 3x times 4x, which gives us 12x squared. The O in FOIL says to multiply the outer terms. 3x times 2 gives me plus 6x. The I in FOIL refers to the inner terms. 6 times 4x gives me 24x. And the L stands for the last term. 6 times 2 gives me plus 12. And many times when you FOIL two binomials like this, your middle terms are your like terms, but you want to make sure that you've combined all your like terms before you're finished with the problem. So we'll combine those. This gives us 12x squared plus 30x plus 12. No more like terms, so you know you've completely simplified it. The third multiplication problem you may see on the ACT is a little tricky, and a lot of people miss this, so hopefully you'll pay attention to this one out of all three for sure, because you've got the quantity 7x minus 1 squared. And what people want to do, students want to just square each piece, and that won't work. And that will probably be an answer choice on your ACT because that's a good wrong answer. Well, we're not looking for wrong answers, we're looking for right answers. So when you see that exponent 2, I want you to just write this 2 times. 7x minus 1 times 7x minus 1. It's no different than if you had the number 5 squared. You could write that as 5 times 5. So that's what we're going to do. We see the squared up there. We're going to write it twice. Now this looks like the previous example, and we're going to FOIL it. So we multiply our first terms, 7x times 7x. That gives me 49x squared. Our outer terms, 7x times minus 1 gives me minus 7x. Our inner terms, minus 1 times 7x gives me minus 7x. And our last terms, minus 1 times minus 1 gives me plus 1. We're just going to combine our like terms right here that are in the middle, and we get a final answer of 49x squared minus 14x plus 1. No more like terms, so you're completely simplified.